morning, students. So far we have discussed the various methods to solve the partial fractions. And prior to that, we have started the various methods to solve the integrations. So we have completed 6A, 6B, 6C and 6D exercises. And let us continue that integration chapter based on the method of partial fractions. So exercise 6D. Integrations based on partial fractions. The first Roman is evaluate the following integrals. So the first question is integral of x minus 1 by x minus 2 into x minus 3 dx. First of all, x minus 1 by x minus 2 into x minus 3. So you put this integral dx aside, then we got x minus 1 by x minus 2 into x minus 3. So this is a fraction. Which fraction? Proper fraction. What is a proper fraction? Where degree of numerator is less than that of degree of denominator. What is the degree of numerator? X power 1. So what is the degree of denominator? X into x, x square. So 1 is obviously less than 2. Therefore, this is a proper fraction, and partial fractions is applicable for proper fractions. So first of all, let us take x minus 1 by x minus 2 into x minus 3. The partial fraction for which is, since the denominator contains the two non-repeated linear factors. So for every non-repeated linear factor, there corresponds to one partial fraction of the form a by x minus 2 plus here b by x minus 3, where a and b are the constants which are to be evaluated. So let us take x minus 1 by x minus 2 into x minus 3. This is equals to, the LCM is x minus 2 into x minus 3. Now this is a into x minus 3 plus b into x minus 2. So let us cancel the denominators on both the sides. So this is x minus 1 is equals to a into x minus 3 plus b into x minus 2. So since x minus 2 is a linear factor equated to 0, x minus 2 equals to 0, x equals to 2. So x equals to 2 is the root, and root has to satisfy the equation. So is the case with x minus 3 is also a linear factor just like x minus 2. So equated to 0, x equals to 3 we will be getting. So let us substitute x equals to 2 and x equals to 3 in this equation. Put x equals to 2, we get 2 minus 1 is 1, a into 2 minus 3 is minus 1, b into 2 minus 2 which is 0. So from this a is equals to, we get minus 1. Likewise put x is equals to 3. Let us substitute. 3 minus 1 is 2 is equals to a into 3 minus 3. This is 0. So b into 3 minus 2 is 1. From this, b is equals to 2 we get. So now this is equals to x minus 1 by x minus 2 into x minus 3. This is equals to, the value of a is minus 1. So this is minus 1 by x minus 2 plus the value of b is 2. So 2 by x minus 3. Now integrating on both sides. Because this is the question. X minus 1 by x minus 2 into x minus 3 dx. This is equals to integral of minus 1 by x minus 2 plus 2 by x minus 3 dx. So this is equals to minus 1 minus, I have separated it from the process of integration, 1 by x minus 2 dx plus 2 I am separating from the process of integration, x minus 3 dx. So this is integral 1 by x minus 2 dx. Integral 1 by x dx is log mod x. This is log modulus of x minus 2 plus 2. This is log modulus of x minus 3. So this is m log a is log a to the power of m. So log, of course, plus c, constant of integration will be there. So m log a is log a to the power of m. So log x minus 3 whole square minus log of x minus 2 plus c. So this is the form log a minus log b. What is log a minus log b? Log of a by b. So this is log of x minus 3 whole square by, this is x minus 2 plus constant of integration c. Let us see the next question. Integral of x square by x plus 1 into x plus 2 whole square dx. So here this is again a proper fraction because degree of numerator is 2 and degree of denominator is x square into x cube. So degree of numerator is 2, degree of denominator is 3. Further, the denominator contains x plus 1, one non-repeated linear factor, x plus 2 whole square. This is a repeated linear factor repeated twice. So therefore, x plus 1, x plus 2 whole square. So the partial fractions for which is, this is type 1 and type 2. The combination of type 1 and type 2. What is type 1? The denominator contains non-repeated linear factor. Type 2 says repeated linear factors. So first of all, consider x square by x plus 1 into x plus 2 whole square. So since x plus 1 is a non-repeated linear factor, there corresponds to one constant, a by x plus 1 plus x plus 2 whole square, repeated linear factor repeated twice. There will be two constants, b by x plus 2 plus c by x plus 2 whole square. So this is equals to x square by x plus 1 into x plus 2 whole square is equals to, the LCM is x plus 1 into x plus 2 whole square. So this by x plus 1, these two gets cancelled, a into x plus 2 whole square plus this by this. So x plus 2 whole square cancelled for once. So therefore b into x plus 1 into x plus 2 we get plus c into this by this, x plus 2 whole square gets cancelled, c into x plus 1. I'm just doing the LCM, that's it. Now this on both sides gets cancelled. We are left with x square equals to a into x plus 2 whole square plus b into x plus 1 into x plus 2 plus c into x plus 1. Now x plus 1 and x plus 2 are the two factors, so equated to 0. So x equals to minus 1 and x equals to minus 2 are what we are going to take and substitute in this equation. Put x is equals to minus 1. Minus 1 whole square is plus 1. So a into minus 1 plus 2. 2 minus 1 is 1. 1 square. This is 2 minus 1. 2 minus 1 is 1. 1 square 1. Plus b into, on substituting minus 1 here, minus 1 plus 1 is 0. 0 into this whole will be 0. Here also minus 1 plus 1, 0. So we are only left with a into 1 square. So from this, a is equals to 1. Likewise, put x is equals to minus 2. Substitute. Minus 2 whole square is 4. On substituting minus 2 here, it will be 0. Minus 2 plus 2 is 0 square. 0 into a, this is 0. Here also minus 2 plus 2 is 0. Into this is 0. So we are only left with c only. C into the value of x is minus 2 plus 1 is minus 1. Minus 2 plus 1 is minus 1. So minus c is equals to 4. From this, c is equals to minus 4. Now, so since the denominator contains two factors, x plus 1 and x plus 2, so we are done with this substitution of x. So, to obtain the third constant, we need to compare the coefficients. So, comparing the coefficients of x square on both sides. Whatever we can compare. So we can even compare with the coefficient of x, or we can compare the constant on both sides as well. So here x square quotient is 1 in the LHS. Here on expansion of this, x square plus 4x plus 4. So x square quotient is a here. So x into x is x square. So x square quotient is b. So a plus b is equals to 1. So from this, b is equals to 1 minus a. So 1 minus a is 1. So 0. So therefore, we get x square by x plus 1 into x plus 2 whole square is equals to the value of a is 1. So 1 by x plus 1. The value of b is 0 we get. So leave it. C value is minus 4. So minus 4 by x plus 2 whole square. Now let us integrate x square by x plus 1 into x plus 2 whole square dx. So integral of this dx. So integral of 1 by x plus 1 dx minus 4 integral of 1 by x plus 2 whole square dx. So integral 1 by x plus 1 dx is log mod x. This is log modulus of x plus 1 minus 4. What is integral 1 by x square dx? Minus 1 by x. Minus of minus is plus. 1 by x is x plus 2 plus constant of integration c. Third question is integral of x plus 3 by x minus 1 into x plus square plus 1 dx. So first let us consider this. X plus 3 by x minus 1 into x square plus 1. So here this is again a proper fraction with a degree of numerator is 1 and degree of denominator is x square into x cube. So 1 is less than 3. So the concept of partial fractions will be applicable to this proper fraction, point number 1. And the denominator contains x minus 1. This is of the form ax plus b. 1x plus minus 1. And this is non-repeated. Had it been the power of a whole square, whole cube, etc., then it would be the repeated linear factor type 2. But here it is not repeated. This is a non-repeated linear factor. For every non-repeated linear factor, there corresponds to a partial fraction of the form a by ax plus b. Here a by x minus 1 plus x square plus 1. This is non-repeated irreducible quadratic factor. Why irreducible quadratic factor? X square plus 1 does not have the real roots. Of course, the complex roots do we have? X square equals to minus 1, x is equals to root of minus 1. So that is the imaginary root. So here we are not getting the real roots. Okay. So this is irreducible. And b square minus 4ac if you take, then less than 0 we will be getting. So here this is 1x square plus 0x plus 1. This is the form. So what is b square minus 4ac? B square. This is a, this is b, this is c. What is b square? 0 square minus 4ac. 4 1 into 1. So this is minus 4 which is less than 0. So that means it doesn't have the real roots. So now, since the denominator contains the non-repeated irreducible quadratic factor, for every non-repeated irreducible quadratic factor, there corresponds to a partial fraction of the form bx plus c by ax square plus bx plus c. Type 3 I am talking about. So this is bx plus c by x square plus 1. Since a is used instead of ax plus b, I have taken bx plus c. Now, a, b and c are the constants to be evaluated. This implies x plus 3 by x minus 1 into x square plus 1 is equals to, the LCM is x minus 1 into x square plus 1, a into x square plus 1 plus bx plus c into x minus 1. LCM I have taken. This on both sides gets cancelled. So therefore x plus 3 is equals to a into x square plus 1 plus bx plus c into x minus 1. So here we only have the linear factor in the form x minus 1. So x minus 1 is the factor where if you equate it to 0, x is equals to 1 is the root which we are going to substitute for x in this equation. And then one of the three constants we will be getting by substituting x equals to 1 in this. And remaining 2 we will be obtaining by just comparing the coefficient, because we don't have the linear factors, much linear factors. Only x minus 1 is the only linear factor for which we are going to get one of the three constants, and the remaining we will be obtained by just comparing the coefficient of x square on both the sides, or x or constant. So let us do that. Put x is equals to minus 3, x equals to 1, x minus 1 equals to 0, x equals to 1. So substitute 1 plus 3 is 4. So a into 1 square is 1, 1 plus 1 is 2. So if you substitute this x equals to 1 here, 1 minus 1 is 0 into bx plus c will be 0. So 2a is equals to 4. From this, a is equals to 4 by 2, which is 2. Now, comparing the coefficient of x square on both sides. So x square quotient in the LHS is 0 because we don't have x square term here. So therefore its quotient is 0. So here ax square plus a is a constant. So we are concerned about x square quotient. So x square quotient is a here. Bx into x, bx square quotient is b. So a plus b equals to 0, b is equals to minus a. So that means b is equals to minus 2. Because the value of a we have obtained before, a is 2. So minus a is minus 2. Now comparing the coefficients of x on both sides, or else you may even compare the constant on both sides as well. So here x quotient is 1. So x square quotient initially we have taken here, and we will be getting a constant here. So I am leaving this. Bx into x is bx square, which we have taken it before in the comparing quotient of x square. Bx into minus 1 is minus bx. X quotient is minus b. C into x, cx. X quotient is c. So 1, this minus b if you take to this side, plus b is equals to c. So therefore c is equals to 1 plus b. 1 plus minus 2. 1 minus 2 is minus 1. So therefore we get all the values of a, b and c. Therefore x plus 3 by x minus 1 into x square plus 1, this is equals to a value is 2. So 2 by x minus 1. 2 by x minus 1. Bx plus c. B value is minus 2x. This is minus 2x. C value is minus 1. Minus 2x. C value is minus 1 by x square plus 1. So this is equals to 2 by x minus 1. So if you take minus common here, minus of, this is 2x plus 1 by x square plus 1. Now we need a integration on both sides, because this is the question given. Integral of x plus 3 by x minus 1 into x square plus 1 dx. This is equals to 2. I am separating it from the process of integration. In fact, integral of this dx. 2 I am separating. So integral 1 by x minus 1 dx minus, this is a plus b by c. A by c plus b by c. So 2 I'll separate from the process of integration. Otherwise, this is 2x by x square plus 1 dx. This is minus 2x by x square plus 1 minus 1 by x square plus 1 dx. So 2 integral 1 by x minus 1 dx is log mod x minus 1 minus x square plus 1 derivative is 2x. X square derivative is 2x. 1 derivative is 0. So this is of the form f dash x by f of x. Log mod f of x. So this is log of x square plus 1 minus, what is integral 1 by x square plus 1 dx? Integral 1 by x square plus 1 dx is tan inverse x. So this is tan inverse x plus constant of integration c. And you may even take this as 2 log x minus 1 to be log of x minus 1 whole square. And log a minus log b is log a by b. So log of x minus 1 whole square by x square plus 1 minus tan inverse x plus c. That also you can take. The next question is integral dx by x square plus a square into x square plus b square. So if you take it so how can we solve this? The denominator contains x square plus a square, which is a non-repeated irreducible quadratic factor, because we don't have a roots for this, real roots for this. So corresponds to every non-repeated irreducible quadratic factor ax square plus bx plus c, there will be a partial fraction of the form ax plus b by ax square plus bx plus c. Therefore, it should be ax plus b by x square plus a square, the partial fraction. And for this, cx plus d by x square plus b square. So, a, b, c, d, 4 constants are generated. Therefore, 4 constants to be evaluated. So which is a cumbersome tedious process. So let us find an alternative for this. So what I am doing is I will be dividing with 1 by b square minus a square. B square minus a square by x square plus a square into x square plus b square dx. What I have done is I have multiplied and divided with b square minus a square. So this is equals to 1 by b square minus a square integral of. So this b square minus a square I am writing it to be x square plus b square minus of x square plus a square. So if you simplify this, x square plus b square minus of x square plus a square, if you take the bracket off, so minus x square minus a square. Minus x square plus x square gets cancelled, b square minus a square is what we have left with. By x square plus a square into x square plus b square dx. So this is equals to 1 by b square minus a square. So integral of, this is a minus b by c. A by c minus b by c. So this is x square plus b square by x square plus a square into x square plus b square dx minus, this is x square plus a square by x square plus a square into x square plus b square dx. So x square plus b square, x square plus b square gets cancelled here, and x square plus a square, x square plus a square gets cancelled here. So 1 by b square minus a square integral of, so this is 1 by x square plus a square dx. This integral dx I am distributing for both these integrands minus integral of 1 by x square plus b square dx. So 1 by b square minus a square. So what is the formula for integral 1 by x square plus a square dx, which is tan inverse x? This is 1 by a tan inverse x by a. 1 by a tan inverse x by a. This is 1 by b tan inverse x by b bracket close plus constant of integration c. The next question, integral dx by e power x plus e power 2x. So this is equals to integral dx by, let us take e power x as a common, then we will get 1 plus e power x. Okay, e power x into 1 is e power x, e power x into e power x. Bases equal, exponents are to be added, x plus x is 2x. So this is, this we can write it as 1 by e power x minus 1 by 1 plus e power x whole dx. I have written this to be this. So LCM is e power x into 1 plus e power x. Then 1 plus e power x minus e power x. E power x gets cancelled. So 1 we have left with in the numerator. Now, this is, let us distribute this integral dx for both these integrands. So 1 by e power x dx minus 1 by 1 plus e power x dx. So this is 1 by e power x dx can be written as e power minus x dx minus integral 1 by 1 plus e power x dx. What I am doing here is I will multiply and divide with e power x by e power x into 1 plus e power x dx. So additionally, e power x I have multiplied and divided. So if we cancel these two, we are left with this only. So this is integral e power minus x derivative is e power minus x by d by dx of minus x, which is minus 1, minus integral of, so e power x into, what is this 1 by e power x into 1 plus e power x? If you take this e power x aside, then this is 1 by e power x into 1 plus e power x dx. So can we write this? This is equals to e power minus x minus e power x into integral 1 by e power x into 1 plus e power x dx is this. So this we have written it to be this. So same I am writing like this only, integral 1 by e power x minus 1 by 1 plus e power x dx. This is equals to, this is minus e power minus x minus, so this is, so let us multiply this e power x with both of these functions. So integral e power x by e power x. So let gets cancelled. We are left with 1 dx minus, this is e power x by 1 plus e power x integral dx. Integral e power x by 1 plus e power x dx. E power x into 1 is e power x by 1 plus e power x integral dx. So this is minus e power minus x minus, here 1 dx is x minus, so here this is minus into minus is plus, e power x into 1 is e power x by 1 plus e power x integral dx. Now this is plus 1 plus e power x derivative is itself e power x. So this is f dash x by f of x, which is log mod f of x. So log 1 plus e power x plus constant of integration c. Since integral of f dash x by f of x dx is log modulus of f of x plus c. Now this is equals to e power minus x minus, so this x I am writing it to be log e power x. So why I am writing log e power x? So naturally it has the base e, since it is a Napier logarithm. So log e power x to the base e. What is log e to the power of m? M log a. This x will come forward, log e to the base e. So what is log e to the base e? This is 1. So x into 1 is x. Therefore this x I have written it to be log e power x to the base e minus plus, this is log 1 plus e power x with obviously the base is e. So no need to write this, plus c. So this is minus e power minus x. This is log a minus log b, log a by b. So this is log 1 plus e power x by e power x plus constant of integration c.